Good afternoon, ladies and gentlemen, and welcome to this webinar today on MasterSeries retaining walls. My name's Tommy White and I head up the sales team here, and joining me today answering any questions is my colleague George Brown, who is the head of our technical support department. A little review first of all of the MasterSeries. We've been doing this for over 30 years. And we have three product ranges. We have a building design suite for doing huge big buildings. We also then have a PowerPad light suite, and we have our custom system. You choose what you need. The building design suite doesn't contain the retaining walls by default, but you could certainly add it. The PowerPad has a light version of the retaining walls, and for those of you who are interested, obviously the custom suite, if you only need retaining walls, that's where you would go. So let's just skip past all this very quickly on the building design suite with its interconnectivity and look at the PowerPad here. And we'll see that we have retaining walls down here in concrete and masonry. But of course what we're looking at is the individual modules. We have our analysis and our design, and then we have our standalone modules, and here's retaining walls down there for us to play with. So that is where retaining walls comes into the system, either as a standalone program or part of the PowerPad system. So I'm just going to close down the PowerPad. We don't need to see any more. Press escape from that. Going to start the MasterSeries, and I can see I'm using a 30th of October version of the software. And here we go to the front screen. So we're using a 2018-10 from the 30th of October. It's a single license to myself, some notes down the right hand side, and some shortcuts to files. So we can either choose to go straight to retaining walls from here, or we can just choose it from an existing file. So I'm going to go into some existing files very simply, and here we go, our first retaining wall. So let's look a little bit about what we've got on the screen. We've got our graphics and we've got our bending moment applied, and our capacity line. Since it's a concrete wall, the capacity line is constant. It's not a tapered wall or anything, so it doesn't taper. It's not stepped. It doesn't taper or step for that reason. We have a water table at 1200 millimeters up, and we even have a projection above the wall. Not necessary for the analysis, other than obviously the self-weight of this additional bit is included. So it's a way of getting self-weight onto the wall without having to go to put on point loads and things. So we're designing to EC7 2004 plus EC2 2004. So soils and concrete. Okay, walking through our tabs, we can see down here we have our results, and we can see all our results. We also then have what we call our unity values. We work with unity values. Anything above 1 is a failure, and we'll see how this works in a minute. And then we have our input tabs. So the wall data, the thickness, the projection height, the height, and our toe height, our length, our heel length, and any back soil slope. And then we have some additional information on the base and any front soil. So at the minute I have this a 500, I could just change that up to 6 and make that up to 1100 of soil. Naturally, from a design point of view, it's going to use a overdig of 10% or 500 mil as the code requires. I'm just going to push that very simply back down to 500. And yes, we can type in here, we can override and change that from 300 to from 350 to 300, or in my case, back again. Nibs are very straightforward. Most people don't put nibs in these days because as soon as you start putting a nib in, if I put a 300 deep nib and I put in 300 here, there I go with my nib, but it actually can start to cause me havoc with my design, because you have the additional active pressure against passive pressure, and you actually, the codes are in a losing scenario. So we're going to leave all that as it is. Density is obviously 24, and we can see that it works because everything is white. Let us first of all make it not work, and I always put in the basic geometry and then play around with these values for my footing, my heel and my toe to see what I need to get my pressure. So I need 1200 to get the pressure. Now I haven't actually looked at the soil data yet, so I'm basing it on the default 100 as the soil pressure, and we can have front and back pressures differently if you're wanting to check it differently at the front and the back. If this is being replaced and this is native soil, you can modify those. I'm going to go for the basic defaults here and have no cohesion. We can also model our front soil different from a back soil, and in the full version we can have layered soil, so we can actually here have a sloping layer of soil. So I'm going to keep going. The soil is okay, and props and ties we will look at later. Loading, I have no loading on it because I have my default loading of 10 kilonewtons per meter. I'm going to put an additional load of 5, so I have 10 plus 5, which is 15 coming down here. Now on the drawing there are one or two things that are missing here. Somebody's turned off some of the values. So now we're seeing our other information, including what the surcharge is factored and everything for us. So we're now seeing more information on the screen, so we can turn that on and off. And in this case we appear to have a prop at the base on this little retaining wall. So if I turn off prop at base, then we'll see it is giving us a bearing pressure problem due to my small base and my additional surcharge. So very simply, I can come back to the wall and I can say, well, I can excavate in, so I can have 1406 for my size of base, and that now tells me the physical base, the geometry of the base is satisfactory. As you saw very easily there, we get these identifiers. So now we're looking at the reinforcement, and I'm going to go for C2835, and I'm going to go for 500B reinforcement, and I'm going to go for, in fact I would prefer to see 50 cover on both faces. And then I can see what happens if I reduce my rebar down. 12s gives me a failure with the inner steel, so the inner is this one nearest to the main soil. So I either go back up the 16s, or if I want to stay with 12s, I would have to reduce my spacing right down. So 12s at 100 would do the job, or 16s at 200, and I can play around with all of these. In my case I prefer to see them at 200 centers. It's a nice even number and allows for easier fabrication. So I'm going to change my distribution steel as well down to be 12s at 200, keep it simple. So that's again how simple it is to do your reinforcement. Do you need reinforcement on both faces? Well, the simple answer is no, you don't really need it in the outer face. So you can get rid of it. Do I need it on the top of the base? Well, yes, you do, because that's top reinforced and this is bottom reinforced, so of course you need it on both. So it's very simply going through a simple design process on a retaining wall. So back and look at the different types. We can now see we've put a sloping soil on, and that has given us a little problem with our sliding. So sliding, we need to get more weight, so we need to have a longer base, or we need to prop it. The propping is the easiest option if that is the case. So prop that base and then we're okay. If it's not going to get any props, then we have to think about getting more weight onto the base, and the only way to do that is to either elongate this as it comes down, but that's quite a long process, or if you know your soil has some form of cohesion, you could see that the going to put in the base as having a friction and a cohesion. I'm going to put a cohesion of 10, and that's usually enough. So if you're building onto a clay, you can quite easily argue that you've got at least 10 kilonewtons per meter square of cohesion on that, and it gets you out of that little trouble. Some would argue it's a cheat, but no, if it's properly done, that is totally valid. So coming through, that looks to be the same base, and now we've done the same base, but we've moved to reinforced masonry, even if the person can't spell reinforced. That's better. So reinforced masonry, if we look at the reinforcement, we'll see we have wall steel on the inner face, so we're assuming that we're going to be putting down some form of hollow block with rebar up the middle of it at every 1, 2, 5 centers and 12s, which is a wee bit of a curse. Do I need to have reinforcement in the wall? Well, the answer is yes. If I had no reinforcement in the wall, I would need to come back and make this wall massively big. As you know, it would probably need to be at least 1200 wide to work, and we're still there getting this tension force in that face. So they don't work very well, as you know. If I went back to my 225, since it's a masonry wall now, I could come along and say I want to step it. So I want to step it on the inside, and I want to come down by 450 and out by 225. So 450, 225, and I'm just going to copy that and start repeating that. And we should get, whoops, that was a missing semicolon. We should get a few steps, and we're beginning to get there, but as you can see, this is going to be very, very big because we have quite a reasonable amount of loading on it. I never like these walls. The other solution is to think about going for, say, a 300 wall in masonry, and then have two leaves. So we split it into two leaves, 100, 100 and 100. And we're going to go, and it's these outer leaf bricks or blocks that are the most important because they are the compression. So we would at least be using 10.4s. And we can see that it's not giving us much. If I go to my reinforcement and I ask for cavity steel, so it's recognized that because it's reinforced masonry with a cavity, that it's cavity steel. So I'm going to pop in 12s. It's not going to work. And what do we need to do? Well, we need to do a couple of things. we need to first of all make sure that the bar sizes are right, and secondly make sure our shear is satisfied, and we're not even getting the thickness of the wall for shear. So we need to either increase the cavity or increase the brick, and it's not this inner leaf of brick, it's the outer leaf of brick that we really need to increase. So if I go to my masonry and I say I have an outer leaf of 215, then things are beginning to get better. I'm within 0.2%. Let's get back to our rebar, and obviously we can put in these bars, 20s at 100. Interestingly, it was the increase in lever arm that was causing the havoc, so we could possibly pull it back down. See, 20s doesn't like it, 16s is not strong enough. We could go for 16s at 150, 16s at 150 placed in the cavity, and we are done. So very simply doing a reinforced masonry wall. And I repeat for those of us, and actually we would probably go and use the 500B, slight change. It doesn't actually change very much, but I would highly recommend that you remember that it's not just the concrete that's critical, it's the strength of these blocks. Because if I reduce these blocks down to 2.9 blocks, I get a failure, because that 2.9 is the compressive strength of our cantilever beam. It's our concrete zone, our compression zone has been limited. So obviously 70s would work, 3.6 doesn't work, 5.2s doesn't work, 7s, 10.4s, and we're now working. So these are not shuttering, these are the compression face of the wall. And George is nodding here, I'm sure he sees this all the time in the tech support. So again, very simply, and other little tricks you can work with is obviously your execution classes. I play safe and go for 2 and 2 all the time, but if you've got good quality and good mortar and everything, you can improve your execution and get up there. But obviously, since we're dealing here more with reinforced masonry, it's really a concrete design, and that's not as important, but in general masonry it would be. So that's all the basics covered. What we want to do now is look at the fun and games. So what have I got next? We've just done a reinforced masonry. Stepped. I've just done it for you. You can see here this is quite an extensive degree of stepping. Piers. Not a great fan of the piers, I'll be honest. You have piers, and then you have what the rebar you're going to put into these piers is. So you can add in reinforcement and shear links into this pier for design, in this case as a masonry wall. So hollow blocks, in you come. As I say, not a fan of these days. We've got far better ways of doing it with reinforced masonry rather than piers. And I move along to the next one, and it is now introducing point loads. So we're making things complicated. The wall data is pretty straightforward. What we do have is the additional soil. So if we can see that we've got a back soil that is layered, and the lower layer is starts at 2 meters up and has a 5-degree angle. So starting and coming up. So we're inputting our additional layer of soil, and our lower layer is a more dense soil, as you would normally expect. And what we've also put on this is a lovely point load on the wall. So let's go and look at these point loads, because this is quite interesting. We've got a point load at 900 and a point load at 2500. So these 2 point loads coming down on the wall, and we can even designate if they're live or dead loads. So we can say the second one is actually a dead load from a building and just say it's permanent. We can also then take this and we can say actually this wall load is minus 100 mil. That means it's on the wall, which means that it's not transferred through the soil and some of it go onto the wall laterally. And some note this has no lateral component on the wall. I'm going to make that one another dead load. So we've got this 1 ton load on top. And then, just to make this example very awkward, we have another load sitting halfway down the wall but out eccentric on the air side, on the outside. And this could be due to some sort of walkway or something bolted halfway along a wall or something. So we can do them, and we only show it down there and eccentric like that because we can. It's not something I would be doing every day, but it can come in useful. And likewise, obviously the depth it comes down at, it starts at. So that's our initial additional loading. We put an additional surcharge on. Obviously we have the 10 kilonewton load that comes through both from the BS and the Eurocodes. Back to our loading. We also have this one which we never really looked at and people overlook it. If I come back to one of my previous designs, we could put an additional horizontal surcharge on the wall. So if we were bolting some sort of barrier up here, we could have our obligatory 10 kilonewtons at 850 up as a horizontal surge, giving us a pre-starting wall on that. So let's get back. So now we've got a wall that looks pretty tame, but it's not. It's designed using the highway loading. So let's go to our loads. Nothing there. Highway loads. We have all these additional loading combinations to consider for our different soils and what we want to consider for these. So we've got all these values of loads and factors. So this is your deck and everything on here. So we can do our highway loading. But we can also tick this box and get a bridge abutment, but I've just done one for you. And this gives you your bridge abutment loads as well. So I'm saying I've got a 50-ton load, which is horizontally applied. And somebody isn't drawing his loads, so go to drawing. And let's draw line loads. And we will see there we have our loading coming in. And we don't need weight centers. Back to our highways, and we can see we've applied a 50 as an HA load. So we can classify them by their descriptions and use those to design these walls to the highway loading. Okay, next. And now we come to a steep hawk wall. Steep hawk, or one of those special types of masonry walls. And I'm just going to pull in here and look at steep hawk. For those of you who are unfamiliar, Anderton makes steep hawk. I believe there probably are other types of wall. Now, it may look initially just as a hollow core wall, but I tell you it's not. The reason I tell you it's not is because it's got these little notches in them, and these little notches allow you, and the little big notch as well. That means that these are built without a mortar joint between the blocks horizontally, and you have these bars, these little notches hold the distribution steel, which also then holds the main steel in location at the right point. So you have a lovely fair-faced wall finish with no mortar joints or anything. The whole thing is held together by the concrete that goes along horizontally as well as vertically. So Lovely walls. They come in three sizes. I think it's 200, 256 and 325. All designed to be less than 20 kilograms. I'm selling this for these guys. So we have gone and created some steep hawk walls for you and set out the basic data. So let's look at the reinforcement. Inner wall face is 88 mil to the rebar and 500. So we're talking here about setting the correct distances and spacings of the bars and the spacing of the mesh and the covers all automatically for you to use, so there's no problems there. So automatically these are available. We also have them on our website, and if I was to go to our website and go into the dashboard, there is, I'm not certain if it's in downloads, I think it is in downloads, sample files, trusses. It maybe isn't in sample files, it may be set as a technical note with a link on it. Let me just see. I can't remember. Hold on 1 second. Technical notes. So for those of you who are users of the software, there should be. Use the search engine, Tom, and you'll find it out. So here we are. It is a download, and it's a document, and it tells you how to download then the actual sample file and install it onto your computer. So we provide those. They are now in fact built into the existing versions of the software, so if you have a recent version you should have all these built in. So that's a great extension to the software. So I'm going to come out of here for a second, and I'm going to start a brand new file, and I'm going to call it a retaining wall. And what I'm going to do is I'm going to go to my library file. So library, retaining walls, and I'm going to take these in and get them. And now I'm just going to go File, Save As, and I'm going to come back out of library and save them into my retaining walls, and I'm going to call it and give it a name and save. So I'm now using my own version, at which point I can see which of the three walls I want, and I can then come along and delete the wall I don't want. So I have all the data set up here for me, ready to go. I can turn around and say, well, actually the wall is going to be with a 12-degree slope, and it's going to have the water table at, well, you probably don't want the water table on a masonry wall other than down below, so we'll not worry with that. And you can see it still works. So everything in these steep hawks is quite configured. If I went to 2.1 meters, it doesn't work. At 2 meters, it's on that sweet spot for this small 200 wall. If I was to go to the next of the steep hawk walls, and I then change that up again, it is set to that sweet spot of 3 meters. I didn't realize it was so specific. And then if I went to the third one, the big ones, the 325s, is that, well, actually I can get up to 4.35 probably. And you could go into your reinforcement and put in bigger, but that's pretty chunky reinforcement every 200 millimeters as it stands. So that's all set out for you automatically in the steep hawk walls. Obviously, if I put in a bigger diameter wire, you're 32, I would need to change these centers and covers because it's all going to move sideways, but these are the standard configurations for those. So I didn't think it would take me an hour. I'm going to have a wee look around and see if there isn't um, any questions that need to be answered. If the black background is blue, does it mean it's filled? Absolutely. That's how we work. You get blue here and you get red here. And you can even click on the word to find out why. So I need the soil pressure needs to be longer and the inner wall steel needs to be better for this example because I went to too high a wall. So come down here, and I think, yes, I did put a line load on, so we just take that back off. What package is the highways in? Okay. The highways is all part of the full version. If you have a PowerPad version of the software, walking from left to right, you can configure any of this data. You can set your soil. You cannot do layered soils, but you can have cohesion. Props. If you're in PowerPad, you only have prop at base, so that's very useful. Loading, you don't have additional loads in the PowerPad version other than additional surcharge and horizontal surcharge, if you remember this little surcharge here. Reinforcement, you only have reinforced concrete, not reinforced masonry in the PowerPad version. So if you're dealing with masonry, it will be plain masonry only. So no steep hawk walls, nothing like that. Piers would just be in concrete. Now, I haven't finished looking at all my walls in my previous example. I've just remembered that somebody asked a very complex question, and it was these examples, and I did one for us. And if I just come all the way down to the bottom, we have a basement. So we have a basement, so we know we're going to be propped here. And we have a prop at 3 meters up and a prop at 6 meters up, and then so we have a double basement with the wall. Obviously you would need to think about possibly checking this for the construction before you get up to this height and prop it. So you may need to do two different walls, one for 3 meters and propped, and then one for 6-7 meters and double propped. And I've also put that in, so we can put these props in. The props are all by default static props, but you could put a spring stiffness. So if I took this one, and remember, kilonewtons per meter. So if I want this prop to be able to resist quite a lot, I'm going to put in 10,000. As you can see, even at 10,000 kilonewtons per meter, you get very little actual resistance because it's moved so much. 100,000. Now we're beginning to get there. 1 million, and we're nearly at the full works. 10 million, and there's very little movement. So as you can see, springs are always telephone numbers. So that's kilonewton per meter moving in that direction. So if you're going to do props that are spring, you can do so, but just be careful. Ties is something we don't normally do. It's been in there for a long time. I don't see many people doing ties. Ties are usually pulled into the soil, the opposite from a prop, but the advantage of a tie is it can actually have an angle. So the ties can come in at an angle and be applied down the wall. So instead of propping, you can say I have these ties. but also a tie has a force that is able to generate at ultimate limit state. So you can put that in there and have fun. But again, it's not one that I would be liking to use very often. Props, yes. Ties, of course they exist and you can use them, but it's not something that I myself have much experience on. Obviously your drive, you have program files and program data. We store most of our common information in program data. So the libraries are going to be in program data, MasterSeries, and from there you'll then have library. And in library you should, with the current version, have retaining walls and steep hook walls. So that is where you're going to get those from in the system. Is there a way to create your own reinforcement rebar strength? Good question. Very good question. Obviously, inside any of these, you only have access to what we have set as our rebar. So we have the 425. For some of our African nations are still using that weaker 425. Likewise, you have, I think the 460 was there, but it's been taken out, thank goodness. So those are all you have. However, if I was to come into my utilities and into my customization, I can look at design codes and I can now see what are the grades. So I can turn around and say I want to have the very old 250R. 250 is the grade and R is the designator for the labeling. So you can add in your own grades. You can also add in your own concrete grades, and these are the standard cube strengths, and it automatically calculates the FCKs that go with the cube strengths. So those are all available to you. So certainly you can put in a new grade of steel if you want, or if you want to play the opposite, take out the grades you don't want, and that's available to you. One of the other beautiful things is that all our software can be used in multiple countries to the Eurocode. We have built in the UK and the Euro norm default values. So if you look at the defaults, you will see that you're using an, I think that's an epsilon or something. I can't remember what that symbol's called. I call it the squiggle factor of 0.85, and using 1.35 and 1.5. So that's the national annex, the defaults. If I close that down and I go to the UK value and go to the actions, you'll see it's actually 0.925, but is actually used in the British version, and it modifies this 1.35 down to 1.25 in certain instances, and this is why you have this value in the R codes. So if you wanted to go and create a Japanese version of this, you would go and say, right, I want to start with using the Euro norm, and then I want to copy it. Well, in fact, it tells you what you want to come up for, and I can say Japan, only because I can spell Japan, and say add. So I now have a set of values that mimic the Euro norms, and at this stage I can then go in and say, well, actually in Japan we're going to use 0.95 for epsilon, and we're going to use 1.4 for our basic dead loads, and we're going to have nothing else for our basic loads, but our actions, that's no changes. For concrete structures, we're going to use a gamma S for steel of 1.05 instead of 1.25, and have that decision, and then say okay. So that's now all changed, but only for that version of the factors. So if I save all this, go back to my retaining walls, and I say under design codes that I want to use the Japanese Euro norm, you'll see there are some changes to our answers because we don't have the same results. So the pressures are still the same, but I think the passive is slightly changed due to the difference in overburden. So you can change those as you desire. One thing we haven't looked at yet is the exporting. And we are able to take a snapshot of this. Okay, it's nice and chunky. Probably get away with 250 walls in places. I can say this wall is going to be 50 meters long, but we'll do it in 8-meter lengths. We will accept these basic defaults, and we'll have minimum 500 mil gaps, and we'll go to 8666, and we'll export this out. And out it goes, and it's going to put it into that example. I'm then going to open AutoCAD, fingers crossed, and you will now have a full detailed, hopefully, version of this wall ready for you to just put a few end bars in and finish it off. Does the export work with MasterRC? Absolutely. There is a separate button there for MasterRC, which you can't actually see. So there we go. There's my cross section. I think this is set up for a black background, so I apologize in the color scheme. There's all your marks. There's your elevation and your plan all done, ready for you to do. And it's obviously done it for the 8 meters we asked for in the design. Very, very straightforward. And I'm just going to minimize that, and of course I can also ask for the schedule for that, and there's the matching schedule in the DXF format. So you can see my 8 meters is now 7.9 because I'm giving it 50 millimeters of cover either end on all my bars set out. And I can also see the weight per bar, 1.2 tons. The shapes used, straights and U-bars, is all we've used. 21s and straights, and no 99s. We can even say show me all the shapes. We don't need to, just the used ones, and we can print that out. So that's all straightforward in the DXF. We can also push that to MasterRC as well if you have that. One last thing, how do you learn the software? Well, we have the Learning Center. You can go in, if you're a registered user of the software, into the client area and look at the videos. If you're just trying the software, you can go to the Learning Center directly from that Learning Center, and you can see all the different videos on all the different aspects of the software. And here's a couple on retaining walls, including one on exactly how to use your steephop walls, how to bring them in, how to even save them into the defaults. Very, very useful. So ladies, gentlemen, I'd like to thank you all for coming along today. And if you need to ask me about anything, my name was Tommy White, and my email address is very simple. It's either sales@masterseries.com or direct to myself is tommy@masterseries.com. I look forward to hearing from you all, and thank you very, very much. You all have a great day, and thank you.